Okay, so I mean, I said there's 5 key principles in Passive House, and the first is, as it says, passive is that the building should be passively heated by the sun, right? And so the idea, and we focus on the heating because heating is traditionally the thing that uses fossil fuel to provide that heat energy to the building. So if we get the passive heating right, then we can drastically reduce the amount of fossil fuel we need. So orientating the building so that it's got south exposure and we've got the sun coming through the windows in the wintertime, and then we shade it in the summertime is the first key principle. After that, it's super insulation, so we let that heat in, but the super insulation makes sure that it stays in there. The next one is thermal bridge free. So these are the things like, you often see in high-rise buildings, concrete balconies cantilevering out. They're like radiator fins on an air-cooled engine, right? They're always either losing heat or bringing heat in the summer that we don't want. And so it's eliminating those thermal bridges, which is part of the super insulation package, right? The next thing is air tightness. The cold air leaking into a building in the winter can easily be, attribute 50% of the heating energy that you need for keeping a traditional building warm. Most buildings leak like a sieve, and so in Passive House we make sure that all of the seals on the windows and doors are properly built and addressed, and we test that. In installation, we test it twice. Once during construction, at mid-construction, before we close all the walls up so we can see where the leakage actually is, when we run that blower door test. And then at the end, when it's all finished, we do that final blower door test. And the amount of leakage that you're allowed to do is probably 6 times better than a code-built building. And it's probably like, I would say 20 or 30 times better than some of the traditional buildings in terms of the air tightness. And that was one of the great unknowns. People never used to test buildings to see if they were airtight. And so this is how we can take, in my career, we've always had a rule of thumb of heating a building. It takes 100 watts a meter squared to heat a building. So if you've got a 300 meter squared house, like a 3,000 square foot house like this one, that would need 30 kilowatts in the old speak. But today, that's 3 kilowatts to heat it, right? It's just an order of magnitude difference. And so that's why it's so important. But then the fifth sort of trait of a passive house is it needs to be properly ventilated. Because we've sealed it up, we now need to make sure that we can introduce the right amount of air, and that we do energy recovery or heat recovery on the air that's coming in and out. So we get the right air quality in the building. And so typically, we've got an air change rate of between half an air change or a third of an air change every hour. So that means the whole air volume of the house is removed and then replaced with fresh air. But that goes through a heat recovery device that's usually in the 80 to 90% efficiency range. So we extract all the heat out of it and put it into the incoming air. So there's very little heat we need to supply to that air, and vice versa. In the summer, it extracts the coolth out of the air that we're exhausting out of the bathrooms and kitchens, and in doing that, then you get supreme air quality. And so one of the things I just want to sort of make sure that I make the point on is, because this is often a misconception of passive houses, is that because you're making them airtight, people are like, I don't want to live in a sealed box. Well, of course, that's not the truth. If you, as we tour around in a little bit, you will see that this building has giant opening windows, and that's the idea, is that we, when in the summer or the shoulder season, when the temperatures permit, we swing the windows wide open and we cool it just using natural ventilation techniques. And that's one of the joys of passive houses, is because you can actually open the windows for longer during the year, because you're essentially, you've got excess heat and you're just letting that out. So they actually become even fresher than regular homes that you're often sort of keeping the windows closed, because you need to try and keep the heat in, but the building doesn't do a great job of that. So there's the five factors, right? It's got heat recovery, ventilation. They're airtight when they need to be in the middle of summer and the middle of winter. It's got super insulation. It's thermal bridge free, and it's orientated for passive solar heating.